Okay, so this whole lesson is about solving with imaginary solutions. So my directions for the first part is just to solve. And I'm going to have x to the fourth is equal to 24 minus 5x squared. Okay, so what we're going to do, I'm going to actually solve these all different ways. So the first one, I want us to solve by factoring. So if we're going to solve this by factoring, I'm going to set everything equal to 0. So we're going to have x to the fourth plus 5x squared minus 24 is equal to 0. Now when we come to factor, it's not going to be an x and an x. How come? How come it's not an x and an x? Danny?
There's four solutions, so it will be x squared.
Good. Because our biggest exponent is x to the fourth, this is going to be x squared and then another x squared. And then we need factors of negative 24 that add to a positive 5. So what are factors of negative 24 that add to a positive 5? Philip? You got it, 8 and negative 3. Now that we have our two factors, you're going to set each factor equal to 0. So we're going to have x squared plus 8 is equal to 0. X squared minus 3 is equal to 0. I'm going to move that 8 over. And before this chapter, what would we say? Say we can't do this, there's no real number solution, you can't take the square root of a negative number. Now can we? Absolutely. To undo a square, we take the square root. But don't forget, the minute you take a square root, what do we have to put in front? Plus or minus. So this is going to be plus or minus I root 8. This is still not my answer, because what can I do with root 8? Simplify it. So it's going to be x is equal to plus or minus 2I root 2. On the other side, we have x squared is equal to 3. Square root both sides. X will equal plus or minus root 3. Do we all agree that this was a degree of 4? Right, the equation had a degree of 4. What does that degree of 4 tell us? We're going to have 4 what? The degree of 4 tells us we're going to have 4 what? Okay. We're going to have 4 solutions. Do we have 4 solutions? Yes, every positive counts as 1, every negative counts as 1. So we have 4 solutions. So what else? What do these solutions represent in our graph? So when we say there's a degree of 4 or there's 4 solutions, what does that represent? Good. This represents where it would potentially hit the x-axis. If we were to graph this, would we see this? If we were to graph this, would we see this? No. Why wouldn't we see it? Because it's imaginary. So we wouldn't see this. Would we see this? Yeah, because they're real numbers. So we'd see these two, but we wouldn't see these two. All right, let's keep going. This next one, I want us to solve by completing the square. And we're going to have 2x squared plus 3x plus 3 is equal to 0. Do we complete the square when there's a leading coefficient? No, I need to divide it out. So I have to divide every single term on both sides by that leading coefficient. So now I'm going to have x squared plus 3 halves x plus 3 halves is equal to 0. Your next step when completing the square is you're going to move any number that doesn't have a variable, you're going to move it to the other side. So we're going to have x squared plus 3 halves x is equal to negative 3 halves. The next step in completing the square is you go to your x coefficient and you take half of it. Dividing by 2 is taking half, but what's it also? Dividing by 2 or multiplying by a half. That's what I'm going to do. I'm going to multiply by a half. So I'm going to take 3 halves times a half. So you go to your x coefficient, you take half of it, which is going to be 3/4. Then what do you do with that after you take half of it? You square it. So now we're going to take 3/4 and square it, and we are going to get 9/16. I'm going to add 9/16 to the left side, and I'm going to add 9/16 to the right side. On the left side, this is going to be a perfect square trinomial, so I'm going to make this x plus, and then essentially all you're doing is taking the square root of that last number. So the square root of 9/16 is 3/4. So x plus 3/4 quantity squared is equal to, in this side I have to make a common denominator, so I'm going to multiply top and bottom by 8, so negative 24/16 plus 9/16. So now we're going to have x plus 3/4, that quantity squared, is equal to negative 15/16. Everybody okay so far? Now we solve. To undo a square, we will take the square root of both sides. The minute I take the square root, I have plus or minus on the right side. Can I have a negative under that radical? No, so I'm going to take out an I in the numerator, so I'm going to have I root 15. What's my denominator going to be? Anybody? 4, because the square root of 16 is 4. We're still not done, because we need to get that x by itself. So we have x plus 3/4 is equal to plus or minus I root 15/4. I'm going to now subtract that 3/4 on both sides. So x will equal negative 3/4 plus or minus I root 15/4. They have the same denominator, so that's good. So I could put this all together. Negative 3 plus or minus I root 15 all over 4. How many answers is this? 2. How many solutions should I have had? 2. I should have had 2 solutions. I have 2 solutions. If we were to graph this, would we see it crossing the x-axis at all? No, we wouldn't see it crossing the x-axis at all. Okay, so we solved by factoring, we solved by completing the square. Now we're going to solve by using the quadratic formula. The quadratic formula only works on quadratics. What does that mean when I say the quadratic formula only works on quadratics? Tejas?
Like highest degree is 2.
Good, the highest degree of 2. So could I have used the quadratic on this first one? No, I couldn't have used the quadratic on the first one unless I manipulated things. But as the degree of 4, I couldn't have used the quadratic formula on that. You are only allowed to use the quadratic formula on quadratic equations, and quadratic equations have to have the highest degree of 2. So when I have 2x squared plus 3x plus 3 equals 0, is this a quadratic? Yes, because the highest degree is 2. And the quadratic formula tells us x will equal negative b plus or minus the root of b squared minus 4ac all over 2a. Okay, you guys tell me, what is a? Okay, Jess?
2.
2. What is b? What's b? 3. And c is also 3. So when we come to plug into the formula, we are going to have x is equal to negative 3 plus or minus the root of 9 minus 4 times 2 times 3 all over 4. So we're going to have x is equal to negative 3 plus or minus the root of 9 minus 4 times 2 is 8 times 3 is 24. So we keep simplifying. X is equal to negative 3 plus or minus the root of 9 minus 24, which is negative 15, all over 4. Can I leave that negative 15 under the radical? No, I need to pull out the negative. So x is equal to negative 3 plus or minus I root 15 over 4. Can I simplify root 15? No. So this is my answer. How many solutions should we have had? 2. Do I have 2 solutions? Absolutely. Okay, you guys, do this one. Are we done? What'd you get? Who has an answer for us? X is equal to
2 plus or minus I squared 2
2 plus or minus, what'd you say?
I squared 2.
I squared?
I square root 2.
I squared root 2?
No, I and then a square root.
Oh, I root 2.
Yeah.
Okay, I root 2 all over 3. I got that. Anybody need to see me?
3.
Oh, did I say that and not you? Does anybody want to see me do this? Okay, let's do it. So I'm going to use the quadratic, and I'm going to set this equal to 0. So we are 3x squared minus 4x plus 2 is equal to 0. Our A is 3, our B is negative 4, our C is positive 2. X is equal to negative b plus or minus the root of b squared minus 4ac all over 2a. So now we just plug right into the formula. So we are going to have positive 4 plus or minus the root of 16 minus 4 times 3 times 2 all over 6. Let's simplify. So x will equal 4 plus or minus the root of 16. And then you're going to have negative 4 times 3 is a negative 12 times 2 is a negative 24 all over 6. So then we are going to subtract 16 minus 24, and we will get the root of negative 8. At this point, we can simplify that whole radical. So we're going to get x is equal to 4 plus or minus 2I root 2 all over 6. But we can't stop here. Why can't we stop here? Can't we factor out a 2 and simplify? So when we factor out a 2, we're going to have 2 plus or minus I root 2 over 6. And then you say 2 goes into 6 3 times, and that's where we got our answer from. All right, let's keep going. Process 4. Okay, I'm going to opt to use the quadratic for this one, but before I use the quadratic, I don't want to deal with fractions. So what I'm going to do first is I'm going to eliminate the denominator. Why am I allowed to eliminate the denominator here in this problem? Kai? Because it's an equation. So the way we eliminate the denominator is we look at all of the denominators and we say, what would be our common denominator if we had to make one? Wouldn't it be 6? So now we are going to multiply every term on both sides by 6. And when we do that, we get 3 goes into 6 twice, so we're left with 2x squared. 3 goes into 6 3 times. I'm sorry, 2 goes into 6 3 times, so we're left with 3 times 3, which is 9. 3 goes into 6 twice, which will give us 2, and then a negative 6x. Now I'm going to set this equal to 0, so we have 2x squared plus 6x plus 7 equals 0. Obviously, I would have said let's try to factor this, but there's no way to factor this. We won't be able to factor it. So we're going to now use the quadratic. So we're going to have x is equal to negative 6 plus or minus the root of 36 minus 4 times 2 times 7 all over 4. Negative 4 times 2 is a negative 8. Negative 8 times 7 is a negative 56. And then when we subtract, we're going to have 36 minus 56. That's a negative 20. And now we simplify. So x will equal negative 6 plus or minus, I'm going to pull out an I, but then I could also simplify 20. So it's going to be 2I root 5 all over 4. Is this my final answer? No, because I can pull out a 2 and simplify. When I pull out a 2 and simplify, I'm going to get negative 3 plus or minus I root 5 all over 2. All right, I'm going to make it look pretty intimidating now, but it's not that bad. What's the criteria to use the quadratic formula? Philip? Yeah, as long as it's a quadratic equation, we can use the quadratic formula. So can I use the quadratic formula here? Absolutely. If that were a degree of 4, would I be able to use the quadratic formula? No. So we're going to we are going to say A is equal to 1, B is equal to the quantity of 1 plus 2I, and C is equal to the quantity of 1 plus I. And we know x will equal negative b plus or minus the root of b squared minus 4ac all over 2a. And now we plug in. So I'm going to be careful here. When it's negative b, it's going to be, oh, sorry guys, that b was a negative, right? Nobody caught that, or you just didn't say anything? All right, our b is a negative. So when it says negative b, what am I going to do? Turn it positive, so 1 plus 2i. Plus or minus the root of b squared. Now, our b is the negation of 1 plus 2i. But when I square that, won't that negative just become positive anyway? So I'm just going to write 1 plus 2i quantity squared. Does everybody understand why I did that? Why I just purposely left out that negative? Because if you were going to square, it'd be positive anyway. Minus 4 times 1 plus the quantity of 1 plus I, all over 2. Philip? You okay?
Yeah, fine. I just figured out something.
Okay.
You can square the 1 plus 2i's.
I'm going to. I just first plugged in, and now we're going to do all that sloppy work. All right, so now what I want to do is I need to simplify under that radical. So when I simplify under that radical, I'm going to go over to the side of my paper, and I need to square 1 plus 2i. I cannot distribute that exponent. I need to multiply it out. So we're going to have 1 times 1 is 1. 1 times 2i is a 2i. 2i times 1 is 2i. 2i times 2i is a 4i squared. So we're going to have 1 plus 4i minus 4, which will be a negative 3 plus 4i. So now let's plug this in. We have x is equal to 1 plus 2i plus or minus the root of negative 3 plus 4i. Now I'm going to distribute in that negative 4. So I'm going to get a negative 4 minus 4i. all over 2. Is everybody still okay with all my work? All right, now I'm going to simplify underneath that radical. The positive 4i and the negative 4i will cancel. So now I have x is equal to 1 plus 2i plus or minus the root of negative 7 all over 2. Last step we have to do is take out that negative from under the radical. So x is equal to 1 plus 2i plus or minus I root 7 all over 2. And those are our 2 answers. All right, next one. I want us to find all possible cubed roots of negative 8. Okay, well, all the possible cubed roots of negative 8. What does that mean? That means any quantity times itself 3 times has to equal what? Negative 8, right? That's the cubed root. Any quantity times itself 3 times will equal that negative 8. So do we know what the quantity is? No. So I'm going to say some quantity x raised to the 3rd power has to equal negative 8. The wrong way to do this. Are we ready for the wrong way? Here, the wrong way to do this is saying, okay, well, I'll just take the cubed root of both sides and say x is equal to negative 2. That's one answer, which is correct. But what is the degree of my exponent? Isn't it 3? So how many solutions should I have? 3. How many solutions is this? Just 1. 2.
I saw the 2.
Just one solution. This is just one solution. So what does that mean? I am missing 2 of the other solutions, right? Sometimes you make me nervous, James. Okay, so then how do we do this properly? How do we do this properly so we get all of the solutions? What we're going to do is we're going to move that 8 over, and we're going to get x cubed plus 8 is equal to 0. And I know you all love this so much. What is this? Sum of cubes. This is the sum of cubes. So this is really the same as x to the 3rd plus 2 to the 3rd equals 0. Do we agree? So remember, sum of cubes. When we factor a sum of cubes, it becomes a plus b times the quantity of a squared minus ab plus b squared. Do we all agree my a is x and my b is 2? Okay. Sum of cubes is a cubed plus b cubed. There we go. That's our sum of cubes. Okay, so let's factor. So we're going to have an a plus b, so an a plus 2. Oh, sorry, x plus 2 times a squared, which is x squared, minus ab, so minus a 2x, plus b squared, so plus 4, equals 0. Now we set each factor equal to 0 and solve. So x plus 2 is equal to 0. X will equal a negative 2. Isn't that one of the cubed roots of negative 8, negative 2? Negative 2 times negative 2 times negative 2 is a negative 8. All right, now the other one. X squared minus 2x plus 4 is equal to 0. Can I factor this? There are no factors of positive 4 that will give us a negative 2. So what do you think I'm going to recommend we do to solve this part? Use the quadratic. Use the quadratic. So we're going to have x is equal to 2 plus or minus the root of 4 minus 4 times 1 times 4 all over 2. So x is equal to 2 plus or minus the root of 4 minus 16 all over 2. So x is equal to 2 plus or minus the root of negative 12 over 2. Can I simplify the root of negative 12? Absolutely. X will equal 2 plus or minus 2I root 3 all over 2. Simplify it, and we get x is equal to 1 plus or minus I root 3 over 2. How many answers do we have now?
Would it be over 2?
Oh, it's not over anything. Sorry. I canceled out that 2. Thank you. How many solutions do we now have? 3. We have 2 here with the I, and we have the 1 with the negative 2. How many did we need? We needed 3. All right, you guys try this next one on your own. So I want you once again to find all possible cubed roots of 27. Are we done? I hear some chattering. All right, somebody tell me, what did you get? Danny.
X is equal to 3 and negative 3 plus or minus 3I root 1 over 6.
Perfect. Anybody need to see me do this one? All right, we are done for today.